The Sun is a much larger celestial body than Earth, but compared to some gigantic celestial bodies, the Sun is relatively small with a significant disparity in size. Among these massive celestial bodies, there is one star with an exceptionally large volume. When talking about the largest star, people might first think of UY Scuti. However, UY Scuti was once considered the largest star but has since fallen from that status. So, how large was UY Scuti, which was once considered the largest star? According to scientific observations, UY Scuti's radius is about 1,708 times that of the Sun, approximately 1.188 billion kilometers, equivalent to 7.92 astronomical units. To put that into perspective, the distance between Earth and the Sun is about 150 million kilometers, which is 1 astronomical unit, and 7.92 astronomical units is roughly 8 times the distance from Earth to the Sun. Jupiter is about 5 astronomical units from the Sun, while Saturn is about 9.5 astronomical units away. This means that if UY Scuti were located at the center of our solar system, it would engulf Mercury, Venus, Earth, Mars, the asteroid belt, and Jupiter. However, according to the latest measurements, UY Scuti's actual radius is much smaller than initially estimated. Currently, the largest known star is Stevenson 2-18, located 20,000 light-years from Earth in an open cluster, with a radius reaching an astonishing 2,150 times that of the Sun. If you're not sure what that number means, let's consider the speed of light. A beam of light can circle the Earth about 7.5 times in 1 second. To circle Stevenson 2-18 once, it would take 8.5 hours. Its volume could contain 10 billion suns. If we place Stevenson 2-18 at the center of our solar system, its volume would extend to Saturn's orbit. This means Mercury, Venus, Earth, and Jupiter would all be completely engulfed, and Uranus would be the closest celestial body. Stevenson 2-18 is also one of the brightest stars in the Milky Way, shining about 440,000 times brighter than the Sun. Although some scientists have calculated a more conservative number, stating its brightness is only 98,000 times that of the Sun, it is still extraordinarily bright. If our Sun shone as brightly as this star, we wouldn't be able to look directly at it from Earth, and the entire planet would be scorched. So why is Stevenson 2-18 so large? As a red supergiant, Stevenson 2-18 is currently in the late stages of stellar evolution. The core is undergoing helium fusion reactions, releasing more energy, causing the outer shell to expand rapidly and the star to become exceptionally large. Scientists speculate that when its fuel is completely exhausted, the core will collapse under its own gravity, triggering a dazzling supernova explosion. Ultimately, the core will form a black hole capable of swallowing any matter. Is Stevenson 2-18 the largest star in the universe? Certainly not, because so far we have observed almost all stars within the Milky Way. There are at least 200 to 400 billion stars in the Milky Way. Our current technology cannot observe the data of every star. Due to our position, the stars in these distant regions are affected by factors such as interstellar material, making it impossible for us to see their specific appearance. We can't obtain accurate data about them from Earth. We don't even know how many red stars are in the Milky Way, and the estimate of 200 to 400 billion stars is just a scientific guess. The universe is constantly expanding our understanding. No one knows the limits of the universe. Its vastness surpasses our imagination.